Good afternoon, everyone. Good afternoon, sir. Good afternoon, myself. My name is Abhinav Kocha. My roll number is E20CSE191. I'm from the batch 11, and my topic for the day is blockchain technology. Going ahead, we'll discuss what is blockchain technology. Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems on the blockchain. Each blockchain on chain contains several transactions, and every time a new transaction occurs on the blockchain, a record of the transaction is added to every participant's ledger. The decentralized database managed by multiple participants is known as the distributed ledger technology, also called as the DLT. Blockchain is a type of a DLT in which transactions are recorded with an immutable cryptographic signature called a hash. Going ahead with the history of blockchain, we'll see that the blockchain was initially conceptualized in 1990s, and it was developed since. And going ahead in 2009, it was the concept of Bitcoin was created. Bitcoin as a cryptocurrency was created by someone anonymously called Satoshi Nakamoto. And going ahead, there were evolution of transactions and on a blockchain and contracts on a blockchain, where in 2014 there was a development of smart contracts, and then in the early 2016s there were developments of blockchain-based applications, and in recent days in 2020 we saw the boom of blockchain as in cryptocurrencies, and then also the downfall recently. Going ahead, it has a very enormous potential and a very big use case for the future use. Going ahead with the blockchain properties of blockchain, what are the properties of blockchain? They are immutable and distributed. Which are the two fundamental blockchain properties? The immutability of the ledger means you can always trust it to be accurate, being distributed projects the blockchain from network attacks. Going ahead, we'll see what are the main components of blockchain. So the first one is node application, second shared ledger, third is the consensus algorithms, and fourth is the virtual machine. In the node application, each node must install and run a computer application definitive to the ecosystem which they wish to participate in. And second, talked about this, the shared ledger, the distributed ledger technology. And there is consensus algorithm, which means every node has to provide their own uh, consent. And the fourth one is a virtual machine, which explains itself as towards computer science students. Going ahead, the properties of distributed ledger technologies, as known as DLT. It's programmable, distributed, time-stamped, immutable, anonymous, and secure, which makes it very easy to use, very secure to use. And we can go ahead with the main topic as in how does a transaction occur on a blockchain. So we'll see this example, this flow chart that I've prepared. So in a blockchain, a transaction is requested by a user first, and then a block representing that transaction is created. Then the block is sent to every node on the network, every node on the blockchain, and then the node is validated by every node on the network, and the block is validated. And when the block is validated by that, each node receives a reward as a proof of work, which is typically in cryptocurrency. Then the block is added to the blockchain, and then the blockchain is upgraded indistinctly, and then hence the transaction is complete. Which this indicates the distributed ledger technology, the consensus, and everything that we talked about in the previous slides. Going ahead with centralized versus distributed ledger. So this is an example of a clearinghouse versus a distributed ledger, which has a centralized ledger, traditional banking transactions. Database is controlled by a central authority and trusted third party, whereas in the distributed ledger or a blockchain, each participant has a copy of the database, ensuring immutability. A distributed ledger is a network that records ownership through a shared registry, which means in a clearinghouse, basically what happens is uh, there is only one entity that controls every transaction, and it has the ledger to it, and the public world is not open to see it every like at the tap of the finger. But going ahead with distributed ledger technology, everyone has the copy of that ledger, everyone is aware of the transactions, and which makes the transactions trustless, seamless, and hence a way better way to handle transactions. Going ahead, there are four types of blockchain, which is a public blockchain, a hybrid blockchain, a private blockchain, and a consortium blockchain. These are permissionless, permissioned, and they have a hybrid in between. So public blockchain is the infamous Bitcoin and Ethereum, which we've heard about. They don't have any central authority. Whereas in hybrid blockchains, as is, there are a lot of hybrid blockchains. There are some blockchains Ethereum has and had an integration with, and there are blockchains called Hyperledger, which are private blockchains, and there's consortium blockchain called Dragon Chain, and there are many more examples. They are controlled by a group and they're controlled by an authority as a private blockchain. Controlled by one authority with some permissions and processes are hybrid blockchains. Going ahead, we'll discuss about what is Bitcoin and how it is different from blockchain. So Bitcoin is a cryptocurrency. It is a way of handling transactions. Blockchain is where the transactions happen. Going ahead, we'll talk about what is a blockchain and how it is different from the traditional banking. So the traditional banking we can see as as we discussed earlier, there's in traditional banking there is only one central authority having one ledger, whereas in blockchain there's distributed ledger technology. In blockchain transactions, international transactions happen instantly, and whereas in traditional banking, international transactions take days, and they have to be verified by KYC, and it is hectic. And that's what makes blockchain different and better from traditional banking. So there are a few advantages of blockchain over traditional finance. So it is trustless, unstoppable, immutable, decentralized, lower cost, peer-to-peer, transparent, and it is great in universal banking, which we talked about. Going ahead, as we've talked about so many advantages of blockchain, there has to be the other side to this coin, which means there have to be disadvantages to the blockchain too. So what are the disadvantages of blockchain? One of them is environmental impact, which means the high usage of machine, high usage of GPUs, impacting the environment, consuming more energy. There's personal responsibility because there's no personal authority controlling it, so there's no personal authority, no responsibility. So there's no if something happens on a blockchain, no one's to blame, no one's to blame, no one's to hold wrong off. And going ahead, there are scalability issues because we do not know how much the blockchain can agree and grow. And over that, there are false narratives always. So this was my presentation for the day. I appreciate your time, guys, and really, really, really thank you. Thank you for giving me your time. Thank you, sir. Thank you myself for presenting it, and thank you.